All right. So in this situation, this is going to be the original. F of x is the original. Now, after in a little bit, you'll notice that you don't really even need to even look at the equation. You'll just notice how we're moving the original graph. We don't even need a graph. Okay? Now, inside the parentheses and outside the parentheses are different things. Okay? If we're adding or subtracting something outside of the parentheses, that will be controlling the vertical. Okay? So plus 5, if I add 5 to f of x, so if I add 5 to this answer here, okay, that means that all of the answers are going up 5. Okay, so this would be up 5 to the original graph. All right? This next one here, so if this was a minus 5 outside, it would mean down 5. Okay? Now, here, it's inside of the parentheses, meaning it's controlling the horizontal. So it's controlling this. Okay? So not only is it doing the opposite orientation, it actually is going to be doing the opposite of what you think it's doing. So you might think it's plus 3 means move to the right, okay? But it's doing the opposite of what you think. So this would actually make it move to the left 3. So inside the parentheses controls the horizontal. Outside of the parentheses controls the vertical, okay? So here, and remember, it's always doing the opposite of what you think. So this one, do you see how the 3 is outside of the parentheses? So this is dealing with the vertical. And it's not adding or subtracting, so it's not just moving it. Okay? Here it's going to be stretching or compressing. When it's multiplying by 3 on the outside, okay, remember, we're controlling the vertical. Okay, because on the outside. This is a vertical stretch. Okay? Now, if I were multiplying by something that is between 0 and 1, okay, between 0 and 1, like 1/3, okay, this would still be doing the vertical. How do I know it's vertical control? Because it is on the outside. But it's not adding or subtracting, it's multiplying again. So I know that I have to write the word vertical, and then I have to figure out if it's stretching or compressing. So it's multiplying by 1/3, so it's compressing it. Okay, so this is a vertical compress. Now this one is inside, meaning it's doing the horizontal. It's controlling the horizontal. Okay, so it's not adding or subtracting, so we're not going right or left. Okay, this is going to be actually a stretch or a compress as well. But this time it's a horizontal stretch or compress. But remember, inside the parentheses, it does the opposite of what you think. So you think 3 is going to stretch it, but in reality, it's going to compress it. Okay, here it's inside. Okay, here it's inside, so I know that it's controlling, again, the horizontal. It's not adding or subtracting, so it's not just moving it left or right. It's going to be actually doing a stretch or compress because it's multiplying. So I'm going to write horizontal. Now, 1/3 makes you think it's going to be a compress because it's smaller, but in reality, this is going to be stretching it because inside the parentheses is always the opposite of what you think. Okay? Now here, the negative is on the outside. Okay? So again, we're thinking up and down. So this is a flip. Okay? This is a complete flip over the x-axis. So all of the y's become x's. So if the shape looks like this, right, it is going to be completely flipped. So now instead of pointing down like this, the new shape would actually be pointing up like that. It would graph like that. It would flip it over the vertical. So everything positive would become negative. Everything negative would become positive. Now, if it's inside the parentheses, like this one is, it would be flipping this way. So if I have something like a line like this, it would actually flip over here and end up looking something like that. Okay, flipping over the y-axis. Okay, so it's flipping like this. So that's what that causes to do. If the negative is on the outside, it's causing you to flip vertically. If it's in the inside, it's causing you to flip horizontally. Now let's go to this here. So how do you graph this? Now my recommendation is to use these numbers, -2, -1, 0, 1, 2. So these are the x's that you're going to put into this equation to graph it. Okay? So this is what you're inserting into. So f of x equals 3 times the absolute value of x. So if I put a -2 in here, what's the absolute value of -2? It's 2. 2 times 3, 6. What's the absolute value of -1? I'm going to put it in here. It's going to be 1. 1 times 3, 3. If I put 0 in here, the absolute value of 0 is 0. Times 3 is 0. 1, absolute value of 1 is also 1 times 3. That's going to make 3. And then 2, the absolute value of 2 is 2 times 3. That makes 6. And now I have 3 coordinates, or actually 5 coordinates. So I can graph. So I'm going to go over here. I'm going to graph all those points you just saw. Okay, the first one was -2, 6, -2, and 1, 2, 3, 4, 5, 6. -1, 3, 0, 0, 1, 3, and 2, 6. Now when you graph anything with an absolute value, it's going to make this V shape. Okay? So if you've done this and you don't end up with a V shape, something might be wrong. All right, second to last thing, the domain, all the possible x's. So what x's am I allowed to put in here? You're allowed to put any x in there. There's no restrictions. So all real numbers. Now, if you look at the graph, there is a restriction on the range. None of these numbers are going down here. None of the answers are less than 0. So all of the answers are greater than or equal to 0. So that's the range. Last thing we're going to do is a slope example. Change in y divided by the change in x. So this is a -9. This is the change in y. How did the -9 change to become a 1? Well, it definitely went up, right? Definitely went up, so we're going to leave that positive. -9 went all the way up to 1, so it went up 10. Now, how did a 2, the change in x, so how did a 2 change into a 4? It went up 2. So it's a +2. Okay? 10 divided by 2, the answer is 5. And that's how you do slope.